Today we're going to be looking at factoring expressions. This is a great intro video that you will need as you move into high school, maybe some of the advanced classes in middle school, but also you will be looking at this maybe towards 7th and 8th grade. I would suggest to go back and look at our GCF, Greatest Common Factor videos, which is our basic factoring for numbers. Also looking at our least common multiple LCM videos. That would be good to look at before we start this. This is going to be very helpful as we move into trinomials, binomials, and things like that. So use this as a good resource. All right, so our first problem here, what we need to do is pull a common number out of 20 and 28. Now we do have that variable a, but we see that a is only with our first term and not the second. So that we do need to factor that in somehow, but it's not going to be as much as a concern as it is with 20 and 28. So to go back and review with our GCF, we can always go back to that video. We can start out with 2. So we divide, goes into that twice, or it goes into that 10 times, goes into that 14. And we can do 2 again. All right, so we have 5, we have 7. Now there's no common number between 5 and 7, so we have this multiplied together, so 4 is what we're going to pull out. So we pull out 4, and if we take note, well, look at here, we have 5. We want to make sure that a stays with it though, okay? We add this, well look, we have the 7, and there's no variable with it, so our final factored expression would be this. Now if you looked at our distributive property video, this is what we would start out with. So essentially what we're doing is distributing is the opposite of factoring. Okay, keep that in mind. All right, let's look at one that's slightly more difficult. So we have an x and a y. They are not common, so we're going to have to talk about that when we move into factoring our numbers out. Now we know that we could use 2 to factor out of 30 and 24, but we want to use our largest possible number, which in this case is 6. Like I said before, if you're having issues with that, go back to the GCF video that I made. Well, 6 times 5 will get us to 30. We have the x. We didn't pull the x out because it's not common in both. And 6 times 4 will get you to 24. And then we have a y attached, and same thing as the x. It's not common in both, so we don't pull it out. So your final answer would be that right there. All right, let's look at one that's slightly different from our first two. So we're going to set this up. Now if you take note, I'm bringing everything down and almost filling in the blank. Like the subtraction sign comes down. Let's take a look at the numbers first and worry about the variables last. Okay, so our largest possible number is going to be 6. All right, now in this case we have an x for both, so we can pull that x out. Okay, so the only reason we're doing that, and we didn't do it with our other examples, is that the x is common in both terms. Okay, so that's pulled out. So 6x times 3 will give you 18x. 6 times 4 gives you 24. We do not need to write the x again, okay? But we do need to write the y. Now the y wasn't pulled out because it was not with our first original term, so this would be our final factored expression. All right, let's step it up a bit. So we have this, our skeleton, more or less, our framework. So whole numbers first. Okay, let's take it in stride. So we could use 4, right? But we actually could use a possible larger number, which will be 8. Okay. Now we have an x for both, but we also have an x squared. So watch what's happened here. We're going to take an x out, right? The y is only with the first term, so we can't pull that out. So 8 times 2 will get us 616. But if we look at this exponent in the original, it's to the second power, so that means we need another x here, because when we multiply these x's together, we end up getting x squared. The y will stay here, right? We weren't pulling that out. Now with over here, if you look at what we pulled out, that 8x, well, that's exactly what we got on the inside, so we're just going to put a 1 there. Okay, slightly more difficult. All right, before you get worried, now we got 3 terms now, which is completely fine. We'll take it step by step, like I said. So once again, we'll set it up like this. All right, now, we know that these are all even numbers, so it looks like our starting point could be 2, right? And unfortunately, that's about as far as we're going to get, so we're going to do 2. We look at our variables. There's only an x with the first term, nowhere else. There's only a y with the middle term, nowhere else, so we can't pull out any variables. So 2 times 2 equals 4. We got to factor in that x. 2 times 9 will get us 18. We got to factor in that y. And then 2 times 13 will get us 26. So that's our final expression.